Yes, good morning, students.
Good morning, sir.
Morning. Okay, just let me have some a recap of what we have discussed in the previous class. Aditi, just can you say what we have discussed in the last class? Yes, Aditi. Hello. Yes, Aditi is there. Yes, what about Akshay?
Yes, sir.
Yeah, can you
We
just
did about the energy correlation between signals, and we also derived an equation for angle between the vectors,
okay.
and then
So how the energy of a
uh,
signal is related to the signal vector? What is the relationship between energy of a signal? Ah,
uh,
yeah.
sorry, sir, I didn't get.
Yes, Akshay, you were telling something. How energy of the signal is related to the signal vector?
Sir, the angle between vectors is always equal to energy correlation between the signals, and
I'm asking energy, man. How energy is related to signal? Energy of a signal is related to signal vector. It is the square length of the signal vector, no?
yes, sir, it is square
Uh,
of like.
yeah, squared length of the signal vector. EI is equal to two parallel lines. In that inside we write SI, then square, right? So that's how
Yes.
we say how the signal energy is related to the square length of the signal vector. And I think I told about yeah, correlation coefficient, and then yeah, so keeping with that knowledge, so let me now today discuss about the uh, Gram-Schmidth orthogonalization procedure. Okay, hope you are aware. I think you are studied in linear algebra. Is it possible to say any one of you what you are studied in linear algebra? Gram-Schmidth orthogonalization procedure. Yes, quickly, is it possible to say? No idea. Okay, so let me say what is Gram-Schmidth. Okay, Gram-Schmidth orthogonalization procedure. Think we could find. Okay. So this is a very important topic. What I can say, It does not mean that you don't have to read the previous topic. That is also important because they will ask the derivation, how signal energy is related to the square length of the signal vector. Okay, but there will be one definite problem on this topic. Okay, for 8 to 12 marks they will ask. So that is why you need to be attentive, and you should be focused also to understand what it is, what is this procedure is. Then how do we apply this procedure to determine the basis functions, and as well as how we can express the given signal energies in terms of basis functions. Okay, fine. So to begin with, this Gram-Schmidth procedure is used to determine a finite set of n orthonormal functions. Okay, hope this point is clear. I said Gram-Schmidth procedure. Okay, I think I will write in short. Okay, instead of writing Gram-Schmidth orthogonalization procedure, just I will write GS. Means you should understand is a Gram-Schmidth. Okay, Gram-Schmidth orthogonalization procedure. If I write GSOP, it is expansion of that. Okay, so it is used for what? Is used to determine. I said is used to determine is used to determine a finite set of n orthonormal functions. N orthonormal functions. So the aim of this Gram-Schmidth procedure is to determine the finite set of n orthonormal functions. So what are those orthonormal functions? We all know it is what, pi 1 of t, right? Pi 1 of t, pi 2 of t, and so on up to pi n of t, I can say. Okay. Yes, hope this point is clear. I said this Gram-Schmidth orthogonalization procedure is used to determine a finite set of n orthonormal functions. Okay, so our aim is to find out what is pi 1 of t, what is pi 2 of t, and so on up to pi n of t by using this procedure. Okay, so to begin with that, let me express the finite energy signal, that is SI of t, as a linear combination of these n orthonormal functions, right? Already I talked about that. How do we express the energy signal in terms of the orthonormal basis functions, right? So, okay. So by determining the basis functions, we will be able to express SI of t as a linear combination of these n orthonormal basis functions, I say. Okay, so that each SI of t can be expressed as SI of t can be expressed as a linear combination of a linear combination of these n orthonormal these n orthonormal functions. Okay. So now let me just write the expansion of equation 1. Okay. So equation 1, what is that? Si of t is equal to summation uh, what j is 1 to n, right? Yes, ij by j of t, no? So now let me substitute I as 1. Already I wrote that expressions. So I want you people to say, if I say I equal to 1, then what can I write? Yes, any one of you can say what I can write? I think. Hello? Yes, any one of you can say how can I write S1 of t by substituting I equal to 1 in the expression 1. Yes, quickly I want your interaction also. Equation 1 you all know what it is, right? That is Si of t is equal to summation j is 1 to n Sij pi j of t, right? So here I am substituting first I is equal to 1. So with that I can write the expression for S1 of t. So you can substitute the value of j as 1 to n. So with respect to that, I want to write the expression for S1 of t. Yes, quickly any one of you can say, or you want me to call the names? I said no voluntary basis interaction is required.
S
Otherwise,
one
I
one
will be,
phi one of t plus S one
yeah.
two phi two
So
of t plus dot
yeah,
dot
one
dot S
by
one
one.
n phi n.
Wait, I will let S. First one is S11. You want me to write that expression here? I don't know. Let me write. I think better. Okay, sorry. Function. So as I said, Si of t, right? I know how to express this Si of t, which is equal to what I said. Summation j is 1 to n, right? Sij pi j of t. Okay. So the value of I can vary from 1 to m. The value of j can vary from 1 to n, and this exists over the interval 0 to t, right? So t will be less than or equal to t, and it will be greater than equal to 0. That is the time interval. And I said I can vary from 1 to m, 1 to and so on up to m. Yeah. So now I expect you people to say what is S1 of t by substituting the value of I as 1. Yeah, same people. I expect other people to respond. Already Akshay has responded, and even uh, one more person also, one more student has responded at the beginning. Similar to that, yeah, Shreyas also responded. Okay, even Skanda is responding. Similar to that, whoever is not responded so far, I want them to open up their mouth and say what is the expression I can write. Yes, Rushank, can you say? Rushank. See, calling your name 10 times, there is no meaning if you don't respond. It's a class, right? If you are with me, then I can expect you to respond immediately. If you are not here, if somebody again alerts you that sir is calling you, then if you are responding during that time, there is no point because there is no much time. Yes, Rushank is not responding. What about Neeraj? Yes, Neeraj. What is this? When people don't respond, what is the point? Yes, come on,
Sir,
students. Yeah. Yes, Namita, tell me.
actually, I was confused what was the J value, sir, because I value you told it was 1, sir.
No, I is I value is one means I want you to write say the expression for when I is equal to 1, right? The value of j can vary from 1 to n. Na? So when I substitute I as 1, okay, I can write S1 of t, S1 of t. Okay, means value of I is fixed here. So j should vary from 1 to n. So with that, what can I write? See, as a first this one, when j is 1, I need to expand the summation, right? So the value of I is 1. Then the value of j can vary from 1 to n, I said, right? So the first term is what? I is 1. I am substituting j is also 1. Okay, j is also 1. Then pi 1 of t, since I am substituting j as 1, right? So this is the first term what I am expecting. Just you have to substitute the value of j from 1 to n, keeping the value of I as 1. Hope you understood?
Yes, sir.
So now what can you tell what is the second term? Still the value of I is 1 only. Okay, the value of now j is 2. So what I can write now?
S12 into phi 2 of t.
Yeah, S1 to pi 2 of t. Yeah, that and so on like that. Till where I can write? I can write
S1n into
S1
phi n of
j
t.
value is, yeah, very good, very good. So pi n of t. So this is what I expected. Okay. Yeah. So similarly, yes, other student, any other student, can I know what is the expression for S2 of t?
So it will be
Yes, quickly. Yeah,
S21 phi 1 phi 2 phi 1 of t plus S22 phi 2 of t plus dot 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 plus S2n phi n of t.
very good, very good. So now the value of I is 2, right? So here I need to substitute I as 2. Then j value can be varied from 1 to n. That is why it is S21 pi 1 of t plus S22 pi 2 of t, right? Plus and so on up to where it is S2n pi n of t. Okay. So let me call with this as this as equation 1. Okay, and this as equation 2. Okay, equation 2. So similar to that, any other student can say what is S3 of t I can write?
S3 1 of
Yes,
t phi
S3 of
1
t.
of t plus S3 2 of t phi 2 of t plus dot 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 S3n of t phi 3n phi n of t.
Yeah, S3 1, right? Pi 1 of t plus, so the now value of I is 3. Okay, substitute the value of I as 3 and vary the value of j as 1 to n. That's all, right? S31 pi 1 of t, then S32 pi 2 of t, right? And so on up to where? S3n pi n of t. So let me call this as equation 3. Okay. So like this, I can write up to where? Value of I can vary from 1 to where?
M.
M.
M, right? So the value of I can vary up to M. So yeah, I can say I will just put the dot. It is understood that it can be varied up to M. Okay. So I think for this, other than regular people who are interacting, I expect to answer. I'm expecting answer from others. Yes. Now the value of I is M. S M of t. What can I write? Yes. Others should respond.
SM1 of phi 1 of t
Yeah. Yes. 1 minute. 1 minute. Yes. So the value of I is M, right? So S M1 into
phi 1 of
phi
t
1 of t.
plus
Yeah.
SM2 phi 2 of t
Yeah. S M2 pi 2 of t
etc.
plus and so on up to S.
mn phi n of t.
Yeah. S M n pi n of t. Very good. So can I call this as equation 4? So just I have expanded equation above equation, which is written in the form of summation by substituting the value of I as 1, 2, 3, and so on up to m. So I got these m equations, right? Fine. Yeah. Yeah, that is for Si of t. And I said one more equation, that is what? The integral. I think I will write here only with respect to, shall I have? Okay, I will write down only. Okay. Hope it is noted, everybody. If I move up is fine. Yes, my dear students, is it fine? Have you noted the expansion of these equations? Shall I scroll up? Is it fine?
Yes, sir.
Yeah. Okay. Yeah. One more equation what I wanted to recall here is I said integral, right, from 0 to t, and the product of those orthonormal function, that is pi I of t into pi j of t, right, will into dt will be equal to what I said. Yes, this will be equal to,
For
yeah,
J
equal
equal
to 1.
J
Yeah, for
J
j equal to,
K.
yeah, for I equal to j. Yeah, for I equal to j. Then it will be 0 when I is not equal to j. Okay. Hope you all have remembered this equation. It's also an important relation which you need to know. Okay. Fine. So let me now come to this procedure. So just I wrote what is the Si of t, how I express or expand that by shifting the value of I as 1 to m and j as 1 to n. And the first step is here for finding the value of pi 1 of t, right? I said that the Gram-Schmidth procedure is all about determining the value of uh, a set of n orthonormal functions, right? So as a first step, so let me find out what is the value of pi 1 of t, right? How do I find the value of pi 1 of t? Is there any idea? Looking at the above equations, is it possible to say? So step 1, I think these steps should be followed properly. Then you will be able to apply these steps for determining the orthonormal functions, and as well as you will be able to express the signals in terms of these orthonormal functions for a given set of signals in the problem. Yeah, what can I do in the as a first step to find out pi 1 of t? Is it possible to think? Looking at those equations, equation 1, 2, 3, and so on, I've written. So in equation 1, if I set all the coefficients Sij equal to 0 except S11, what can I get? I repeat once again. In equation 1, I hope equation 1 with respect to today's what equation 1 I have written. Okay. In equation 1, I said set all coefficients. Okay, set all coefficients, that is what Sij equal to 0 except, I'm asking except, I'm writing that in red, except what I said, S11. So with that, what can I write?
S1 of
S1
T
of
By
t
setting,
phi 1 of T.
yeah, so I can write S1 of t, right? S1 of t is equal to S11 by 1 of t. Hope everybody agrees with this. I am setting all the coefficients of Si is equal to 0 except S11. Okay. Hope with respect to that, I can write S1 of t as S11 phi 1 of t. Yes, is this fine? Yes, is this fine?
Yes, sir.
Yeah, thank you. So from this, what can I write for pi 1 of t? Yes, pi 1 of t
S1
is equal to
of
what I can
t,
write?
S1 of t by S11.
Yeah, that's all right. See, S1 of t is equal to S11 pi 1 of t is there. So from this expression, I can write pi 1 of t. So my aim is to determine the orthonormal basis function, right? That is why I'm expressing this in terms of pi 1 of t. So which is equal to S1 of t divided by S11, right? Yes or no?
Yes, sir.
Yeah. So when I get S11, so that is S11 and pi 1 of t, right? Here I and j value are equal to 1, right? Means I equal to j, right? Here which is equal to 1. That means what? Yes, I want you people to say this. See, S1 of t, right? Here the value of I and j are equal to 1. That means what I am saying. What I'm expecting you people to say is the value of pi 1 of t is normalized, right? Understood what I'm saying? But pi 1 of t is normalized means what? Yes, what do you mean by this? See, I wrote the integral equation, right? That is integral 0 to t pi I of t pi j of t into dt. Right here, the value of I and j are equal to 1. So with respect to that, what I can write when I and j are equal to 1? Yes, what can I write that integral equation 0 to t? See, I value is also 1 and j value is also 1. That is pi 1 of t into pi 1 of t into dt, no? Yes or no? Hello? Yes, are you getting my point? See, here the value of I and j are equal to 1, right? So in the integral equation I'm asking, that is integral pi I of t into pi j of t into dt, where the value of I and j which is equal to 1, you want me to write this expression, or if I write it is pi 1 square of t into dt, is it fine? Are you understanding? Yes, is this fine? Because the value of I is equal to j which is equal to 1, I said. Is that fine?
Yes, sir.
Yes, sir.
Yeah. Yeah, with respect to that, so integral 0 to t pi 1 square of t into dt, which is equal to what? It is 1, na? Yes, just now I
Yes,
said
sir.
that condition, right, which is equal to 1. So now let me write, so which is equal to what I can write? I said what is pi 1 of t, right? So let me put this in box so that, yeah, this is the expression for pi 1 of t. So now just I am substituting the value of pi 1 of t in this equation. What is pi 1 of t? It is, see, integral 0 to t, right? So pi 1 of t is what? S1 of t by S11, no? So can I write this as S1 square of t, right, divided by S square 1 1? Yes, can I write like this?
Yes, sir.
Yeah. So now let me solve for S11. Hope this is fine. Yeah, what I get if I solve for S11? Yes, sir. Means solving for S11 means what? I need to express the above equation in terms of S11. Right? Yes, anyone can say? Yes, other students should respond. There is Karunya, Ramya, even many people are there. They don't respond only. I said Neeraj, he promised me that he will interact. Yes, hello. Yes, Manusri.
Yes, sir.
Yes, my dear students. Yeah, you're all there now. Then respond. Yes, solving for S11 from the above equation. What can I write?
So S11
Means,
square is equal to
ah,
integral 0 to t S1 square of t dt.
yeah, right. That is what I expected. Yes, others should respond. See, when I said solving for S11, I am expecting you people to say the expression for S11. Means, first let me write S square 11, right? S square 11 is equal to integral 0 to t, right? I can write S1 square of t into dt, right? So, yeah, now next step, just at least, is it possible to say S11? Yes, Manusri, can you say what is S11 I can write? Manusri. Yes, Manusri is there. Manusri is also not responding. Okay. Uh, yes, what about Vadva?
Yes,
Vadva.
sir. Yes, sir.
Yeah, can you just say what can I write for S11? Already your friend has told S square 11 will be like this, right? 0 to t S1 square of t into dt. What is S11?
So taking square root on both sides.
Yeah. So that's all, right? So I can write S11 is equal to what I can write integral 0 to t, right? S1 square of t into dt, right? I can write square root here, right? So what is integral 0 to t S1 square of t into dt I can write? Yes, quickly people should say. Have I defined anywhere integral 0 to t S1 square of t into dt is what?
S11 square, sir.
No. So that is fine, but you have to think in other way. How do I define energy of a signal? Energy of a signal, I'm asking. Yeah, energy of a signal. See, if I want to find the energy of a signal S1 of t, what is the expression I can write? E1 is equal to integral 0 to t S1 square of t into dt, right? So I can say this is the energy, is nothing but the energy of a signal S1 of t. So can I say which is equal to root of E1, where E1 is the energy of the signal S1 of t. Is that fine? Because I'll write here, because E1 is equal to, I can say integral, right, 0 to t S1 square of t into dt. Yes, is that fine? So with that I can say pi 1 of t. Okay. So now what is pi 1 of t? We have written already, it is S1 of t divided by S11, no? Yes or no? Yes, pi 1 of t is S1 of t divided by S11. Now I can substitute what is S11. So S11 is nothing but root of E1. That is energy of the signal S1 of t. Is that fine?
Yes, sir.
Yeah. So that is why yesterday I stressed upon this energy of a signal. How do I define the energy of a signal? So I expected you people to answer, but not getting response. Energy of a signal. See, every time we will not be able to say, because the first step I have written here, it is fine. So let me call this as equation 5, what I can say. Okay. So I wrote what is pi 1 of t, right? So now I can express the signal S1 of t in terms of orthonormal function, right? So S1 of t is equal to what I can write from the above equation. It is root of E1, right, into pi 1 of t. Is that fine? Yes, I'm asking, is this fine?
Yes, sir.
Yes, sir.
So this is what the procedure is. So our aim is, the purpose of Gram-Schmidth orthogonalization procedure is to determine the orthonormal basis function and express the set of finite energy signals in terms of those orthonormal basis functions. So how do we do that? So this is what the procedure is. So this is the first step, right? So in the first step, I could find out pi 1 of t, and then I could express S1 of t in terms of that orthonormal basis function. Okay. Similarly, next step is what I need to find out. Uh, yeah, what could be the next step? How do we go about next step? Yes, is this clear? First step. Hope everybody understood the first step procedure. Hello. So what I setted all the coefficients of Sij except S11 in equation 1. Right? I setted Sij equal to 0 except S11 in the equation 1. Then I could write the expression for S1 of t as this. Right? That is S1 of t is equal to what I said, S11 pi 1 of t. Then just I rewrote in terms of pi 1 of t, S1 of t by S11. Then I found what is S11, right? So S11, I found that S11 will be equal to what I found. It is square root of E1. That is S11. The first coefficient will be energy of the signal S1 of t. Then I expressed that in the pi 1 of t. So pi 1 of t is equal to S1 of t by root E1. Then I wrote what is S1 of t in terms of orthonormal basis function. Okay. So in the same way, as a hope everybody has written. If I scroll up, is it that fine?
Sir, 1 minute. Can you scroll on top?
Is this fine? This much or still? Yes, still you want me to scroll up?
Yes. Yeah, this much is good.
Yeah. So I substituted, means I set all the coefficients Sij equal to 0 except the first term, that is S11 in equation 1. With that I wrote what is S1 of t, which is equal to S11 pi 1 of t. Then I expressed it in terms of pi 1 of t, right? So pi 1 of t is equal to S1 of t by S11, right? Since S11 means the value of I and j both are equal to 1, so I can say that integral 0 to t pi I of t pi j of t into dt will be equal to what I can write, integral 0 to t pi 1 square of t into dt. So which is equal to 1, right? When I equal to j, which is equal to, then that becomes 1, right? So with that I wrote the expression and I substitute the value of pi 1 of t in that equation. From that I could find out what is S11. So I found that S11 is equal to square root of E1. Right? So the first coefficient S11 is nothing but the square root of the energy of the signal S1 of t. Then I said pi 1 of t is S1 of t by root of E1. So S1 of t will be equal to root E1 into pi 1 of t. Okay. Yeah. To go ahead in the similar fashion. So now the step 2. Okay. The second step is to set all coefficients of Sij equal to 0 except S21 and S22 in equation 2. Okay. The step 2 is so now our aim is to find out what pi 2 of t, right? We need to find out pi 2 of t, and I need to express S2 of t in terms of pi 2 of t, right? So to do that, what I am doing in the second step, I am setting in equation 2 in equation 2, set all coefficients what Sij equal to 0 except what? Except S21 and S22. Okay. So with that, what is the expression I can write? I think any one of you can help other than regular interaction students. Yeah, quickly. Yes, quickly. Any one of you? Yes, Abhishek Reddy. Abhishek Reddy. Yes, Abhishek Reddy is there. Not responding. What is this fellow?
Yes, sir.
Yeah, can you tell me the expression, man? By setting Sij equal to 0 except S21 and S22 in equation 2. You know what is equation 2? That is the expression
Yes.
for S2 of t. Okay, except S21 and S22, rest of the coefficients are set to 0. So with
S2
that,
of t
what is the
equal
expression I can write for S2 of t? Yeah,
S2 of t is equals to
yeah, S2 of t is equal to
S22.
S22. Oh, why S22, man? What is the first term, man? I said the
First
S21 and
term.
S22 are not set to 0. Yeah,
S21
yeah, S21
phi 1
pi 1 of t. Yeah,
phi
S21
1
pi
of
1 of t plus
plus S22 phi
uh,
2 of t.
yeah, very good, man. S22 pi 2 of t. So this is what the expression I get. So rest of the terms all becomes 0, right? So can I call this as equation 6 if I am correct? I am continuing with that. Okay, fine. Okay. So now the next step is here in the step 2 only. So what I do is I multiply this equation 6, okay, both sides by pi 1 of t, and then let me integrate over the interval t. Hope understood what I said? I said multiply, okay. I do this mathematical, this one, multiply equation 6, both sides by what value? By pi 1 of t, okay, and then and integrate, just I am writing symbol, okay, and integrate over the interval 0 to t, integrate over the interval t, okay. Yeah, so with that, yes, Nagaveni, can you say what can I, if I multiply the above equation by pi 1 of t, and then first let us go step by step, okay. If I multiply by pi 1 of t, what can I write, ma? Nagaveni? Yes, Nagaveni is there.
Yes, sir.
Yeah, I have written here, right? Equation 6. Hope you are able to see. Hope, are you able to see the equation 6? Yes, Nagaveni. Nagaveni, no. Yes, what about Gautam Hegde? Gautam Hegde? No, Gautam Hegde also. Yes, Muhammad Anas.
Yes, sir.
Muhammad Anas. Are you able to see the equation 6, man? I am asking, are you able to see the equation 6?
Yes, sir.
So I wrote the statement here. What I wrote, multiply equation 6
is both sides.
both sides by pi 1 of t, right? And then
Yeah.
integrate over the interval t. So can you just tell what can I write for that? If I do that, means I need to integrate. Okay, first I need to multiply equation this both sides by pi 1 of t, right? So first term is what? S2 of t into pi 1 of t.
Yes, sir.
S2 of t into pi 1 of t into dt. Then I should write integral. So I wrote first. Okay, fine. Which is equal to then S2 1, right? Then what? Pi 1 of t into pi 1 of t,
Square.
right?
Yes,
Pi
sir.
1 of t into pi 1 of t into dt,
Plus.
just integral 0 to t. Okay. Then next one is what? Plus, next term is there, right? Next term is what? S2 2, then pi 2 of t, right? This has to be multiplied by pi 1 of t into dt. Again, you integrate this also with 0 to t. Yeah. Now what is the expression I can write? What is the simplification I can do here? Hope you able to understand what I am asking.
Last term becomes 0.
Yeah, last term becomes 0 because
The integration rule we have.
integration rule or orthonormal basis rule.
Orthonormal property.
Sir,
Yeah,
because they are
because
normal.
here pi 1, yeah, they are orthogonal to each other. So right, pi 1 of t, pi 2 of t. So since I is not equal to j, so this term will become 0. Very good. Then here pi 1 of t into pi 1 of t, right? So integral 0 to t pi 1 square of t into dt, which is equal to 1, right? So can I write S21? Can I say S21 will be equal to, right, integral 0 to t 0 to sorry, here I think I wrote S21, right? That is not correct. When I said S2, right? Hope understood? Because S2 of t expression I am multiplying by pi 1 of t, no? It is S2 of t pi 1 of t into dt, which is equal to integral 0 to t S21 pi 1 of t into pi 1 of t into dt plus this term, right? I said this term will be equal to 0 because they are orthonormal, and then I can write uh, S21 because this pi 1 of t into pi 1 of t, it is pi 1 square of t, right? So integral 0 to t pi 1 square of t into dt is equal to 1. So that is why with respect to that I am writing S21 is equal to integral 0 to t S2 of t, sir. Okay. So S21 is equal to what? Integral 0 to t S2 of t pi 1 of t into dt. Is this fine? Yes, is this fine? I'm asking.
Yes, sir.
Because here see pi 1 of t into pi 1 of t, yeah, pi 1 square of t into dt, right? Which is equal to 1. I can write S21 is equal to this one, right? Okay. So I could find out what is S21 is, right? So now the next step is, means in the step 2 only. So let me take the intermediate function. Okay. So I let I call that intermediate signal as G2 of t. Okay. So let G2 of t is equal to, I can write S2 of t, okay, S2 of t minus S21 pi 1 of t. S21 pi 1 of t. I am letting the intermediate signal, which I call it as G2 of t, which is equal to what I am writing, S2 of t, okay, minus S21 pi 1 of t. So let me call this as equation 7. Okay, and this signal, the intermediate signal G2 of t is orthogonal to pi 1 of t over the interval 0 to t. Okay, so this intermediate signal, as I said, which is orthogonal, okay, which is orthogonal to pi 1 of t over the interval 0 to t. Okay. Okay. So based on our step 1 understanding, right? So I wrote there pi 1 of t is equal to what I wrote? Pi 1 of t. Anyone of you can say the expression what I wrote for pi 1 of t? Yes, quickly. Pi 1 of t. Find that is equation 5. What is that?
S1 of t
Pi
by
1 of t.
S1
Yeah,
of
S1 of t by root of E1, right? I said root of E1 is the, yeah, root of E1 is the energy of the signal S1 of t, right? In the same way, I can define the second basis function. Okay, I can define the second basis function as, so we can define second basis function yeah, any one of you can say with respect to that G2 of t is my intermediate signal, I said, right? So based on that, can I define my the second basis function as like this, pi 2 of t, right? Pi 2 of t is equal to G2 of t divided by what? Square root, that is energy of the signal G2 of t, na? Square root of E1, right? Means here it is G2 of t, right? So can I say
So that'll be S22, no?
sorry, no, I'm asking, say I took intermediate signal as G2 of t, right, which is equal to S2 of t minus S1 pi 1 of t, right? So I'm writing the intermediate, that is the second basis function with respect to that intermediate signal. So here it is G2 of t, right? What is the energy of this? That is square root of E1, I said, right? In case of pi 1 of t. Similarly here, it is square root of this G2 of t. That is, what I can write is square root, right, of energy of this signal. Hope you're understanding what I'm writing. 0 to t, G2 square of t into dt. Yes, hope this point is clear. See, with respect to pi 1 of t, I said S1 of t divided by root of E1. What is E1? E1 is the energy of the signal S1 of t, right? Here, I have considered the intermediate signal, that is G2 of t. So, which is equal to what I said? G2 of t I defined as what? S2 of t minus S21 pi 1 of t, right? So, to find the second basis function, I am defining pi 2 of t as G2 of t divided by square root of the energy of the signal G2 of t. That is what I wrote here, 0 to t, G2 square of t into dt. Is this fine? I'm asking.
Yes, sir.
Sir.
Yeah. So just now let me substitute the value of G2 of t is what here, right? So I can write pi 2 of t is equal to, yes, what I said, g2 of t is what I said. It is s2 of t, right, minus s21 pi 1 of t, s21 pi 1 of t. And similarly in the denominator, I can write square root of, right, then integral 0 to t, yeah, so it is g2 square, right? G2 of t is what, this one, right? S2 of t minus S21 by 1 of t, right? So this is square into dt. Just I substitute the value of g2 of t here. So now you need to do some simplification process here, sir. So this is my pi 2 of t, which is not yet simplified. Okay, I brought it to in this form. Okay. So this is my pi 2 of t. And even from this onwards, I can generalize for pi I of t. Means the value of I can be anything. So I think let me take a further simplification and generalizing this expression for pi I of t. I think in the next class. Is that fine? Sorry. Is it okay?
Yes, sir.
Because already Anand is in a hurry. Before he says, let me stop. Hello, na? Yeah, at least I think till this procedure is fine. How we are going about this? Just have a look, and we'll have a discussion further how to generalize this basis function for finding any value of pi n of t. Okay.